Okay, well, we're having a little bit of technical difficulties this morning that we're working through, but we will do our best with that. So you've joined the introduction to both PostGIS. My name is Kim Nelson. I am a board member for GIS LIS as a state government rep, and I am a regional GIS support specialist. I also have Steph Boyum with me. And we're going to be introducing the instructors. For this first few minutes, we will probably ask for your participation to make sure the virtual machines are working correctly. But we have Dr. Bill Mitchell from MinGeo as a GIS developer and Mike Dalbo from the Minute with the Department of Education GIS coordinator. Hi, Mike. I am going to say if for this first portion, go ahead, unmute, we'll have a discussion. But once the presentation starts, of course, mute yourselves. It should be at the bottom left-hand part of your screen. There are icons along the bottom middle. And if you want to use the chat, there is a chat option for you there. Feel free to, as the presentation starts, ask questions there, and I will be monitoring that between myself and Steph. With that said, I'd like to go ahead and turn it over to Bill and Mike. And Mike will be following along in the chat. He's having some internet issues with the storms that came through last night. Maybe that's what's going on with the virtual machines. So welcome, everyone. Glad to have you.
Yeah, thanks. So good morning. I'm Bill Mitchell. My pronouns are he and him, and I'll be working with everybody on PostGIS this morning. So the first thing to check on is how are folks doing with being able to access and log into the virtual machines. I know that Mike and I had some issues getting in earlier. I've been able to get in eventually, but yeah, if you can please let us know in the chat if you're in or not in, that would be great.
We can just go ahead and go down the participant list and let us know if you are able to join if you are using that. So we got Devin Power.
Hi, yeah, good morning. I am able to join, however, I'm at the university location and I cannot join via their Wi-Fi. So I'm on the on a hotspot coming off my phone. So if there is any sort of sequencing such that we're maybe going to see some demonstrations and then do stuff on our own, might be useful for me to understand that and be able to pop back and forth between the regular old Wi-Fi and my phone that can actually access the virtual machine.
Okay. Good to know.
Andrea Bergman. Are you all set up?
Good morning. I was just working on it right now.
Okay, I can come back. Anish?
Yeah, hi. Yes, I'm able to log into the virtual machine.
Okay, great. Thank you. Looks like Jill.
Hi, good morning. I clicked the link and a window popped up. It said my virtual machines class in progress, but I didn't actually log into anything.
For the virtual machine?
Yeah, so I'm confused. The email had a link, visit URL to register your workshop VM. I clicked on that. Is there a login to the actual remote virtual machine I'm supposed to see? Because I don't see that.
Yeah, so I'll, oh, I can't share while I'm sharing other things. So stop this one. Start this one. So you should see something similar to this. Does that
Yes.
sound good? Then there's this little computer icon,
Okay.
and you should click on that.
Yep.
And at least if you're in Chrome, it will download a little .rdp file.
Okay.
Then you can open that up, and it will ask if you want to connect. You say, of course I want to connect.
Okay. And it looks like it's just wanting the password.
And hopefully yours doesn't do what mine is doing here, which is taking forever and then not working. So
It says it's connecting. Okay, I see it.
great.
Thank you.
So, let's see, how about Carl? You're the next on my list. You able to get into the virtual machine if you're using it?
I'm in.
You're in?
Yep.
Perfect. Nancy,
I'm in.
wonderful. I have two Carls in here. Is that?
That's me. I realized I joined originally on my phone for the audio piece, but I think I will just close that one and have the computer one call on my phone. But the audio just works better.
Okay, thank you for letting me know. Andrea, are you able to get in?
Yep, I'm in.
Huh. And are you on the state device?
Yes.
Hmm.
Should I not be able to get in?
Well, we were having some issues with Bill and Mike, and it's interesting. I thought it would maybe be a full network thing, but we'll figure it out.
Okay.
And then getting back on the Wi-Fi, I will connect to see if there's a potential. I believe it was Devin is what I had here on getting. Is there a Wi-Fi password that you need to get into that, or are you
No,
just?
we're on the university or trying to use the U of M guest network here at the physical location, and presumably a necessary port or something to that effect is not configured correctly because it just won't unable to connect to the remote desktop from that network. The hotspot on my phone here is working fine.
Okay. I would bring back Bill. Is there going to be any interaction where he would probably need more than the hotspot?
I don't think so.
Okay.
Most of what we're going to be doing is pretty small scale. There are a few things where it gets a bit more computationally intensive, but all of that is happening on the remote server that's nice and big. So
yeah, not worried about the computational thing here. Just my battery life more so than anything. So if there was more of a structure to this that we were going to be seeing and then doing ourselves, such that I can flip back and forth between those various networks. I don't need to be connected to the remote machine at all times if that's how it's going to go. Or if we're going to be constantly working in the virtual machine, I'll just follow along until the thing dies.
Yeah, we're going to be pretty constantly working
Okay.
in the remote machine. But I think I'll be sharing my screen most of the time, and we'll we'll get through it.
Great. Thank you.
Bill, we are having one more person that just jumped on. I'm admitting them currently. Tyler. Once he's on, we'll just confirm with him. He's gone. I will try and readmit him when he is available. Oh, here he is. Tyler, we see you just joined. At this point, we had done some introductions, but we want to confirm that you are able to access the virtual machine for class today. Would you mind unmuting yourself and letting us know? If you need more time, that is fine too. You know, I can probably work with some direct. Tyler, if you want to go ahead and get started.
Okay. So I will go ahead and toss into the chat. There is a link there to the file that we'll be using to sort of guide our way through there. Okay, so thanks again for joining this morning. I'm really excited to be talking with you about PostGIS, and I suspect Mike is as well. So as was sort of in the synopsis, this is an introduction to PostGIS for folks who have familiarity with SQL, but aren't necessarily like DBAs and in SQL all the time. So we're going to start out with sort of an overview of why PostGIS might be a good thing to use. We'll then move on to getting into the basic spatial data types and operations, how to manipulate points and lines and polygons. And then we'll use that to build up some more complex things based on relating different spatial and non-spatial data, and ending up kind of building out some workflows with that. And then finally, we'll talk about some more advanced considerations and capabilities and places to ideas of where to start digging deeper to get into PostGIS. So why PostGIS? So it does solve a few different problems that are common to working with spatial data. As folks who've worked with lots of shapefiles know, there can get to be some sprawl of files, and if you have multiple people working on a single project, keeping a central source of truth can be difficult, and you spend a lot of time managing shapefiles and moving them around, and that can get pretty messy pretty quickly. And also, shapefiles don't allow for multi-user access. It's sort of one person can work on it at a time. It's often nice to have multiple people be able to access it and work together. With the databases, you can have some enterprise controls like role-based access controls. so that you can give people in one part of the organization or on one project access to read or write a specific thing, but other people can be kept away from that data. So it's able to sort of segment and compartmentalize who can access which data. And it also lets you keep your data in a more normalized sense. So you're keeping fewer copies of data around, and we'll get into that a little bit more in a little bit. There are a number of nice things about PostGIS. So first, it's free and open source, which are two great things going for it. It's under active development. This has moved quite a bit in the last few years. There's been a lot more functionality brought into it and a bunch of refinement in terms of how it, in terms of performance. And so it now performs a lot better than it did a few years ago. And as Mike points out in the chat, having normalized data really helps with maintaining data, particularly for the data that's under your control that you edit and need to maintain frequently. So I guess we should say a little bit about what is this normalized data that we're talking about, and that is where you have the specific pieces of data are kept separately from each other. So for instance, the classic example is if you have, say you have a DVD rental store or a video rental store. You have some number of customers and you have some number of videos. You need to make sure that you have, kind of customers get their own table and they can be related to videos, but you may not want to have a table that talks about which customer has which video at the same time, and then you just add and remove from that so that you have all the information on the entire customer plus all the information on the video in that same row of the database. So being able to normalize it so that you keep all the information about the customer in one place and all the information about the video in another, and then you build up the relationships between things. That's where having normalized data helps.
Yeah, Bill, I think I'll just add in here too, like from a spatial perspective, which you'll show. One of the things that having data in a database and using spatial functions gives you is the ability to do things like, well, say you're maintaining your facilities or your street markers or some other kind of event data that's under your control, and you want to be able to regularly report out what legislative district that's in or what county that's in or what city. The spatial functions allow you to do that, and you don't have to maintain it all yourself.
Yeah, good point. Thank you, Mike. Some other nice things. PostGIS does support vector data. It does raster data, and it can work in 3 or 4 dimensions, and that 3 dimensions can be 2 spatial dimensions in time, or it can be 3 spatial dimensions, or it can be 2 spatial dimensions and a linear measure, or it can be all 4 dimensions. So lots of possibilities for high dimensionality. And you can do your geospatial work in the database. So you don't have to have all of your spatial data moving from the database to a machine where it gets processed and then put back into the database. You don't have that network connection going through there. So that's kind of nice. It interoperates with a whole bunch of different spatial tools. And so that's kind of the way that you can make things that otherwise wouldn't interact with each other be able to interoperate. So some people like QGIS, some people like the ARC stack. You can get all kinds of tools that will all interface with PostGIS. For output, you can get GeoJSON and vector tile output directly from PostGIS. So that can make things easy for if you're trying to have exports for web display or web mapping. That makes things easy to use and makes it so that you don't need a whole lot of middleware to be able to serve that data. And then there are a variety of different extensions available. So you can use the foreign data wrapper extension to connect to things like shape files or file geodatabases or Excel spreadsheets or CSVs or Oracle databases or SQL Server. And it can query all of those things as though it were a Postgres table, or you can just refer to it like it was right here in Postgres. There is a geocoder that can come with PostGIS, the Tiger geocoder, which runs on the US Census data. That can be useful for at least some applications. And there's a routing extension if you need to do routing through a road network or a utility network. That's a thing that's available as well. So let's actually get going. And before we get into the SQL part, it's time to make sure that we're all connected to our database and getting started with that. So for those folks who are connected to your machines, which should be everybody, go ahead and open dbeaver, which is our database client. While that's opening, are there any questions so far, comments?
I do not see any come through.
Okay.
Mike did say that this is within your virtual machine, as Bill is showing.
Okay. So once that is up, you'll want to right click on the PostGIS workshop connection and then go to edit connection. And you'll get a screen like this, and the username and password is what you will need to change for this. So in the email that I sent you on how to get logged into the machine, there should be some type of, at the bottom of that email, there was a username and a password. So go ahead and put the username and the password in here. And if you want to, you can test the connection using the test connection button. And if it works, you should see a little box pop up saying, yes, it works. And you say okay to that and okay to the connection. And then you can double click on the on that connection and it will open. So I'll pause a moment here for folks to get in. Okay. So if you use the little menu expansion buttons, you can see that there are a whole lot of different schemas in the database, and these schemas are sort of a grouping of data sets. In this case, these almost all correspond to a user. Says I realizing that there are some that aren't in here yet. And so what you'll want to do is, if you expand the main schema, that will show you the different things that you have available to you. And the main schema is common to everybody. And if you aren't able to get into that, please let us know in the chat, because that has a few different tables within it. Okay.
No news in the chat is good news.
Yes, that is very good news. Okay. So then, yeah. So to give a little bit of background on what these data sets are, the precinct data set is the electoral precincts in Minnesota's 5th Congressional District. And that covers the city of Minneapolis. Then the parcels are the parcel and land record parcels from Hennepin County. Those are current as of late March. The mock polling place is a set of fictitious but not outrageously so polling locations. And then facilities is a non-spatial table that, say, has some information about where these polling places are and sort of who are the facility contacts for that, so that if someone were administering an election, they would know who to talk to and where things were in a contract process. So the
sorry to interrupt you. Tyler is having some problems with the database credentials.
Okay.
Just a heads up.
Yeah, okay. Let me see what I can do about that.
Well, there's the Goose username, Bill.
Yeah. I'm realizing that I'm in I'm in on a place that I wasn't intending to be, because
Hey, you know, since I can't get in, I can share my credentials with Tyler if that you think that'll work.
It might. Yeah, you can go ahead and do that. All right. So, then you can go to Open SQL Console. If you want a SQL script, it will let you. You'll be able to save it afterwards. I typically like to just run commands, and if I need to, I'll copy them out and save them elsewhere. So go ahead and open a SQL console. And here you can type a command, and pressing Control Enter will run the current line. Or you can highlight some and press the little red arrow. So if we come back to our README, first thing that we're doing is we'll go ahead and make a point, and we'll specify that it should be in WGS 84 projection. So we can copy that from our README, paste it in here, press Control Enter. And we get back a point, which looks a whole lot like what we fed it. And then if we expand this window, this window, this window, you can see that our point is here at the Minneapolis airport. But if you don't want to use WGS 84 projection, you can specify a projected coordinate like UTM-15. So we can copy that. Paste that in, and again, press Control Enter to run the current line. And you'll notice that our map doesn't look nearly as nice anymore. And that's because the leaflet map only works in some of the other coordinate systems, and then once you go into projecting it, it doesn't know. It only previews in a small handful of coordinate systems. So if you're not using one of these, your preview may not work like you think it will. Now you might ask, what if we have more than 2 dimensions worth of data? And what if we want to take our point that's in WGS 84 and we want to project it into UTM-15? It's a little bit more complicated. We use the ST transform function, which will reproject the reproject things into the coordinate system you give it. Here we tell it to make it UTM 15 north. It will make our point with a Z and an M coordinate. And we tell it that those coordinates are in WGS 84. So when we run that, oh, it's again in UTM 15. And so dbeaver doesn't preview that nicely, but as Mike pointed out in the chat, this will open nicely in QGIS or in anything that understands projected coordinate systems. This will work out okay. If we want to actually get to confirm that we get the right answers out as we're specifying this transformation, we can have it select or tell us what is the X coordinate, what's the Y, what's the Z, and what's the M, plus give us the geometry back. And we use a subquery here. And so this says first, run this query, or sorry, this query, where it will transform this point, which is specified in WGS 84. It transforms that into UTM zone 15 north. And then it takes that result, just that one point, and has it then return the X, Y, Z, and M coordinates plus the point as a geometry. So when we run that, we can see that there's a big number for X, an even bigger number for Y. The Z stays the same, the measure stays the same, and we have a geometry that, again, it's projected, so we aren't able to preview it here. But that is where it should be. And I guess at this point, are there any questions folks have? Because if not, we might try opening up QGIS and showing a little bit about how to work with the database in QGIS as well.
There were a few questions for me in chat that I was able to handle. That's good. This seems like a good point. You know, you demonstrating that the coordinate transformation bill. You know, I think hopefully we'll have time to talk about this later about other spatial databases. But coordinate transformations is one of the things that spatial functions in SQL Server can't do. So it's really, really handy. So, but love to see if anybody has any questions.
Okay, well, hearing none, let's go ahead and fire up QGIS. This is the fancy new release, so it's got all kinds of fun bells and whistles in it. Though I will apologize, I didn't actually get all the database connections preloaded in here. So we'll work through that together. Or did I? I preloaded the OpenStreetMap and a view. So go ahead and open the PostGIS Workshop QGIS project. And then in the browser where it says PostGIS, we'll add a new connection. For the name, it's going to, we can call it Workshop. For the host, we go back to dbeaver. We go to edit our connection, and we can copy and paste the host from our existing connection because it's a mouthful. The port is still 5432. And the database is election singular. From there, we can test the connection. It will ask for a username and a password. And those were again in the email that was sent to you. Oh, excuse me. The SSL mode. The SSL mode should be set to prefer. Let's try that. It worked.
Bill, why don't you leave that connection
Yep.
dialogue up for folks so they can follow along with themselves. And while we're here, Nancy was asking, what's the M part of the coordinate? That could be either a measure of time or like for linear referencing systems, right?
Yes. So the M, it's for measure, which is, yeah, it's often either a linear reference distance along a stream or river or along a highway or road, or it can be typically a timestamp. And I think the general convention for timestamps is seconds since January 1, 1970. And so that provides a way to then start working with trajectories, and there are in fact PostGIS functions that will tell you what's the closest approach between two. If you have two, say two buses on a bus system, what's the closest that they ever were at a given point? So, good question. Okay, well, let's go ahead and we'll finish this connection here in QGIS. And up at the top of QGIS, there is a little entry for, or a menu for database that has DB Manager as the only option. Go ahead and open that up as well. And with that, you can again see the different schemas that are here. And if you use the little wrench on a table icon, it will open up a new SQL query window so that you can enter queries in here. So if we go back to our latest query that we used in dbeaver, we'd have this select X, Y, Z, and M and projected it into UTM 15 North. We will select, we will copy, we will paste it. And then when you press execute, it will run the whole, everything that's in the window. So with this, you do have to be careful to select the part that you want to run. I'll make it a little bigger. We can execute that. And then there's a little box at the bottom to load as a new layer. So we're going to check that box. It asks for a column with a unique value. In our case, there's only one row, so they're all unique, but we're going to use the measure. Typically, you would have a feature ID in here, and you would use that, but our measure will be unique today, so we'll use that. And then the layer name or prefix, we're going to call this projected point. And we load that. And when we look at our window, we now have a point that is here by the airport. And so that's a way that you can be doing your spatial queries and pulling them into to QGIS if they're in a projected space and you want to see them.
Hey, Bill.
Yep.
Could you show the QGIS connection file again? There's no service name configured, right? It's just
right. In fact,
just
service name
info
should
host.
be blank.
Right.
Service name should be left blank.
And the port should be 5432.
5432. The big thing is the SSL mode does need to be set to prefer.
And when you choose no authentication under that configuration box, then it prompts you, right?
Yes, it will prompt you every time that you need to, every time that you open that connection, it will ask for a username and password.
Okay.
There are ways to save it that you then use a QGIS master password. That's a little beyond the scope of what we'd like to get into here. So we're just going to do it the once and it'll work for today. And it's great.
Okay. Well, if other folks have continuing problems, just feel free to direct message me in the chat and I'll do my best to help.
Okay. So coming back to the README, another way that we can display our spatial text is as the extended well-known text. So you may be familiar with the well-known text format, which tells you whether it's a point, a line, or a polygon, and then what the coordinates are. The extended well-known text goes one step further. It's a PostGIS thing, and it tells you also what coordinate system are you using. So we can come into our really either dbeaver or QGIS, but we aren't loading this into QGIS, so dbeaver will be fine. We can load that in, and it will tell us that we have a single point, and it has one coordinate with these coordinate values in our spatial reference. So that can be kind of a handy way if you need a human readable geometry that you're debugging. That can be a way to get it. Now that we have points, we can make lines. So for this query, we start by making a couple of points, and those points are arguments in the stMakeLine function. So it makes a line out of 2 points, and then we tell it, here's our spatial reference, and that will then give us a line that runs from near Winstead to Shakopee. Another question that folks didn't necessarily ask, but I'm sure you're wondering, is what's all this ST business in front of all these PostGIS functions? And ST stands for spatiotemporal. That is space and time-based functions, and that is part of a ISO standard and sort of convention around naming geospatial and spatial temporal functions in a way that they can be recognized as, oh, that deals with space and or time. So that's why the ST prefix on all of the functions. So stMakeLine doesn't just work with single points, but you can actually use multiple different lines. So in this case, we're using that well-known text input for 2 different lines, and we're making a line out of those 2 lines, and again telling it what the coordinate system is. And our preview shows that we have a little dipper in Minnesota. So that was all fun, but let's get into actually using this to take a look at some of our data. So far, we've just been been feeding it one piece of data at a time in very small chunks. Let's use something a little bit bigger. So we're going to make a line that goes through all of the polling places in order. Though I think before we do that, let's just get a count of the number of polling places that we have. So we have 134 polling places in our Minneapolis polling place data set, or fake data set in this case. And if we make a line that goes through all of those, we do end up with a bit of a convoluted geometry, but it runs all over the place. And we do have a linear feature. Practical use of this one may not be huge in this particular example, but you might have other things that you want to make into a line, and so you do that by selecting the geometry that you want to, that is the points from the polling place. You put them in order. You then turn those results into an array, and then the stMakeLine function can operate on that array, and it says, oh, I have an array of points to put into a line, and it then builds out the line. And that, again, can work on 2-dimensional points, but also 3- and 4-dimensional points. Now that we have points and lines, it's time for some polygons. They work really similarly to points and lines. We can again use the stMakePolygon rather than make point or make line, and then feed it a well-known text line string to the geom from text. And when we make that, it creates our polygon from Winstead to St. Paul to somewhere in the greater Owatonna region. And with that, once we have these lines and these polygons, there are functions stLength and stArea, which you may well be familiar with from other GIS packages. And those do exactly what you think they would do. It will get the length of a geometry, or length of a line, or the area of a polygon. Typically, those are returned in map units. So if you're working in the WGS84 space, the answer that you get from those may not be quite what you're expecting. So you typically want to be in a projected space for those. Another thing that comes up is that not all the geometries that you work with are simple geometries where there's just one feature. Sometimes you have multiple point, you'd have multi-points or multi-lines or multi-polygon features. And PostGIS is a little bit finicky in how it lets you store data. So it's often best when you're adding points, lines, or polygons to a table that when you're bringing them in, that you explicitly cast them to a multi-form of whatever they are. And you can do that with the st_multi function. And so we can convert our single point into a, so that it will declare its type as a multi-point, even though there is only the one point there. So it says it's a multi-point. It will be stored as a multi-point, but there is only the one. One thing that then becomes necessary is that sometimes you need to split multi-part geometries into their individual components. And sometimes you need to go back the other way and you need to then take those split apart components and squish them back into a single multi-part geometry. And the parcels data set is a great example of this because there are a number of parcels that are multi-part in Hennepin County. So what we're going to do is we're going to take just the state PIN, which is the parcel identification number, and the number of geometries for the shape, and we're going to see if there are at least 15 parcels that have a multi-part geometry. And there are. In fact, one of them is a 9-polygon geometry. So then to split that apart, we'll use the st_dump function. And st_dump will dump out the multi-polygon or multi-point into its single constituent parts. And when it does so in that it will hold it will return both a path number, which is the number of that point or line or polygon, as well as the geometry for it. We also use the row number function, which gives us an ID that's going to be unique over all of these. So if we run this query, we get a bunch of geometries back. And each of these now are single polygons. And we limited ourselves here to 15 results because Hennepin County probably has a whole bunch of these. And then, if you have multiple points that are each in their single sense, you can collect those together using st_collect, and that will turn them from a single point into a multi-point. And here, again, there are even multi-points where there is only a single piece within it. But others of them do have multiple points. So how are we doing? Folks feeling good so far? Okay, got a thumbs up from Mike. Great.
Bill has a question in the chat.
Okay, how are individual polygons with holes or islands treated? That is an excellent question. So PostGIS conforms to the OGC polygon model. And for this, there is a really good discussion about that here in the PostGIS validity page. PostGIS handles holes and islands by saying that the this outer polygon is a square, and then there is an inner hole, which is this square or diamond square. So that is how PostGIS treats it, is that this is two squares. Esri takes a different approach to this. Esri says that this polygon goes to a node here, then around these nodes internally, touches only at that point, and then continues around. So in the Esri model, this is all a single continuous croissant-shaped feature, whereas in the OGC model, which is what PostGIS uses, this is in fact two distinct rings. Yeah, so that was a good question. It can the two can communicate to each other, but as I have been finding with some of the parcel work that I'm involved with, translating between the one format and the other can sometimes be a little bit tricky, but I think that the well-known text and well-known binary formats specify which model it's supposed to use. So you can generally translate cleanly between the two. But great question, and I don't know, Mike, if you're able to find this and put it in the chat, that would be great. The PostGIS validity was the search term for it. So that's a little bit about points, lines, and polygons. So far we've talked about ST make point, make line, make polygon, the set SRID, which tells it here, your numbers have this coordinate system. ST transform, so you can change which coordinate system it's in. Can output it as the extended well-known text, can get the geometry from text. The ST X, Y, Z, and M functions. ST dump to make multi-parts single parts. ST collect to make single parts into multi-parts. ST length and ST area. There are a number of other functions that are kind of along these same lines. ST add point will add points into you can take a line and say st add point, and it will add that next point into the line. St boundary can get parts of it out. St dump points can take your polygon or your line and just make it into a whole bunch of points. There are a lot of these functions. This is just the tip of the iceberg, and most everything that you could want to do is already there and ready for you. We'll take a quick pause for any questions. I think we're doing okay, but. Okay, so spatial queries. Querying data on spatial relationships is, of course, one of the things that one wants to do with a spatial database. So in a regular database where you might want to relate things based on IDs or a shared property, we can do that with spatial data. So suppose that we are working alongside election administrators to prepare for an upcoming election. We have a number of precincts, which are non-overlapping polygons. We have a number of parcels, quite a few of them. Technically, you would probably want to use a building layer, but I don't have a building layer and I have a parcel layer, so we're using parcels as a proxy for buildings. These are polygons, but they can overlap and do. And then then we have points, which will be our fictitious polling places. And additionally, we have that facility contact information and contract information that's as a stored non-spatial table. So we can make our non-spatial data visible in a spatial way by using a SQL join with an appropriate spatial feature. For instance, our non-spatial facility data set, we can join to the polling place based on the facility ID. So this is kind of like if you have something that's by county, and then you can join that tabular data that's split by county to a county map, and now you can visualize that or analyze that on that spatial basis. So we can, by doing that, we have our spatial stuff kind of all in one place that we can use and come back to. And we can have all of our non-spatial things that have a way to be linked with that spatial data, but they don't need to be saved with that spatial data. So we don't need to keep a separate copy of the geometry for all the counties in each place that we actually want to be able to visualize it with the county. So that's where one of these big advantages of the spatial database comes in. So let's go ahead and we'll join those facilities to the polling places. When we do that, we can see that we have now what you might think of as a feature class where we've got our IDs. We have facility names. We have precinct names, and we've got points. And in this case, our unique key in here is actually the precinct name, because the ID that we have is the facility ID.
Bill, the join is actually done on the ID though, right?
Yes. So the join is done on that facility ID. So yes. So the facility ID in the mock polling place is equal to the ID that's on the facility, because when you're making contracts with Sarah over at the Pillsbury School, the contract and the contact information is going to be the same regardless of the number of precincts that will be voting there. So yeah, you're joining on that ID.
Yeah, for me, this really gets to the heart of the advantages of normalizing databases, because lots of times we're in charge of like maintaining, the spatial locations of things, right? And somebody else is in charge of maintaining, the contacts or the people or sort of transactions and other things. And being able to join those two things in a view like this or a query just saves you so much time.
Yeah, and with this, it also means that now, if you wanted to have a map where you can symbolize the contract status differently based on where it is, you can do that. And if the underlying location of where is the, I mean, I don't imagine that the locations move that much, but if things move, then that spatial component changes independently of the rest of it. So here we were able to attach tabular data to spatial, but what if we actually wanted to now do some full relation of spatial things to other spatial things? These are things like what contains, what's in something, what touches something, where's the nearest coffee shop, where's the nearest lake. For doing point in polygon type of analysis, we can use the ST contains. So that will be ST contains is true if geometry A contains geometry B. So let's find the parcels that contain a polling place. And this is one where I'm going to suggest that we try that actually in the QGIS database manager, because this is one that we're probably going to want to actually see on a map and look at a little bit. So let's paste that in there. We will, because it's QGIS, we'll need to select the part that we want to run, and we'll run it. That looks pretty disappointing, doesn't it? There are no results returned. And the reason there are no results returned is because we weren't being careful about our spatial reference IDs. So let's try that again, but this time we'll transform our mock polling places into UTM Zone 15 North, which is what our parcels are in, and it's appropriate for where in the world we're working. We come back into the QGIS database manager, we paste in our query, we run that, and now we have 389 rows back. And it has figured out that our ID column is an ID. We can tell it that our geometry column is called shape. And we'll call this parcels with polling places. And there was an error.
Did you have multiple queries in there?
Shouldn't. But that 389 looks high. This is where there is in QGIS, we can view the log messages panel. And it tells me that my ID was not in fact as unique as I hoped it was.
Bill, could you show where that log is available again?
Yeah, so the log is available under View and Panels and Log Messages. So in this case, I think I did run the whole, yeah. I did accidentally run the whole thing. There we go. Okay, so if I limit it to 10 to avoid the non-unique key problem, I can then use the Zoom to Layers button, and I can see that in Northeast Minneapolis, we have a number of parcels now that have been identified as containing polling places.
So Bill, I think we're about halfway through, right?
Yep.
Might be a good time to either pause for questions or a short break, or we can certainly keep going if folks want us to.
Yeah, let's take a pause for questions, and then any questions at this time. Okay, hearing none, then yeah, let's take a. Well, let's see. I've got 10:26. Let's take a 5-minute break. So we'll be back at 10:32. Sound good? 10:32. We'll be back. All right. Let's get going again here. So we just found at least some of the parcels where they join with the polling place. We can also find, and this is a little bit more of a complicated query, but we can find the precincts where the polling place isn't within that precinct. So maybe we want to know, which places don't have, or which places need to go outside of their precinct to go vote. So again, we'll do this in the QGIS side. Paste that in. Make this bigger so I can see what I'm writing. So we get 24 rows out of that. So we should be able to use the precinct as a unique ID. The geometry is going to be WKB geometry. And this will be precincts with external polling place. We can load that. And if we zoom to that layer, we can see that there are a number of precincts across Minneapolis where the polling location isn't within the precinct itself. So to create that query, we looked at the precincts. That the precinct data set needed to have a name like Minneapolis, because Congressional District 5 does get outside of Minneapolis. And then we want it where the precinct ID isn't one of the ones where the precinct contains the polling place for that precinct. So it's a little bit of a convoluted way to get here. So we it starts with this we find all the precincts where the polling place is in the precinct. And then we take the inverse of that. The indexing here was not the best, but still this query took a quarter of a second. So that was, I'd say that's doing pretty well. There's definitely room to improve this one based on better use of indexing. So if you're really getting into how to use PostGIS and learning all the things about indexes, this is one where it was not the best indexing in use here. To find the distance from each precinct to the middle of the polling place, or from each polling place to the middle of the precinct, The ST centroid and ST distance functions are good for doing that. So here we'll be selecting the precinct, which is the precinct name, and then the distance from the centroid, making sure that that precinct is in our UTM coordinates, and our mock polling place again in UTM coordinates. And we join that by the precinct and the precinct name, and we're going to order it by biggest distance to smallest. Oops. So we run that. We find that the biggest distance between the precinct centroid and the polling place is a bit over 2 kilometers. And then the smallest one is within 32 meters. So that was pretty centrally located. So that's the kind of analysis you might want to do if you want to make sure that there's good accessibility to your polling locations and that nobody has to travel particularly far to get to that location. Now, you may have noticed that we've been reprojecting stuff a lot. And if we had a bigger data set, the reprojections would take longer. And it just gets to be a pain. So there are a number of ways that you can deal with that. One way is to change the projection of the source table. So any additions or updates that you make to that data will then need to be in the new projection. But that's an option if it's data that you control and that you'll be editing and maintaining. If it's data that comes from somewhere or someone else, you may want to take a different approach. So one approach is to create a view to do the reprojection. So for that, the database will end up doing an on-the-fly reprojection every time that you query it. But if there are additions or updates made to the data, the view handles things automatically. You don't have to touch things, and the data always stay fresh. If your server has a lot of RAM and good caching, and you don't have a huge amount of data, this may or may not be a good solution for you. Another option is sort of a middle road, which is the materialized view. So in this case, the database reprojects the data once and stores the result, but that result can become stale. So after you add or update or delete to that original data source or that original table, the materialized view will need to get refreshed to bring that new data in. For data sets that don't change very much, you can just do that manually, or you can set it up to run on a very, very slow schedule, monthly, quarterly, annually, whatever. Or you can create database triggers, which is well beyond the scope of this discussion, to automatically refresh it. There's great discussion on Stack Overflow as to what your options are and why you would want one or the other. But that's, yeah, there are ways that there are ways to deal with this. I would typically like the materialized view approach, though note that it does create a second copy of your data. So that's a concern if you have a particularly large data set. There's also, with this particular query, there is some chance that some of you may have problems running this query, and I apologize for that. We aren't going to end up coming back to it, though, so it probably won't make a big impact. So what we're going to do is we're going to create a materialized view. The if not exists, make sure that we aren't going to actually replace it if it already is there. We're going to define that view as being the OGC feature ID, the precinct ID, county, and then the ST transform of that WKB geometry into the UTM zone 15 north. So we're making that precinct into, now we're transforming it into a new coordinate space. The with data says that not only should you create the view, but you should actually then put the data into it now. It's possible to create the view and then say, I'll update this later, or I'll ask you to refresh it later, but we want it to be set and refreshed now. So we run that. And it didn't like something about that. What did it not like? There may be some version issues, but for some PostGIS version issues that we just found there.
And if folks are successful in doing this, that'll create that view in their schema, likely, right?
Yes, that should. If you go into the schema that corresponds with your username, and this is where I'm afraid that some folks are likely to have problems because I'm not sure I made all the schemas. But you should be able to then look in the you should be able to run a refresh on the database objects. And hopefully that should, please refresh. Okay, it looks like there was at least a little bit of success in getting this to work. Mine apparently did not go where I was expecting it to, but I'm pretty sure that this materialized view precinct is mine. And if we open up that that table, we can see that it now has different polygons for those features. And they're in the right coordinate system so that now you could do further analyses in the coordinate system that you wanted it to be in. Then when the source data change, all it takes to do to update that view is that you just refresh materialized view and then the name of the view. Yes, and Mike, that's a good point in the chat there that in many cases it's good practice to specify the schema name before the table or view or materialized view name, because then that tells it explicitly where to go. So if I in dbeaver console, if I put the build.mvw precinct, run that. Now I have my materialized view. And I can refer to that view using the schema qualified build.mvw precinct. I can run that, and now it's refreshed. If I had updated the data in the source table, this would now be all up to date. It's a similar story for doing the mock polling places. We can create that materialized view if it doesn't exist, and transform those data into the new projection.
That one's probably back in your main schema.
Oh
now.
yeah, I bet it is. Yeah. Okay. So that's in the main schema. Actually, about what happened is that it already probably existed there, and so it wasn't created. So that's how to create these materialized views, and they're really handy, particularly if there's something where you work a lot with a data set that doesn't change a ton, and you want the you want to split things out into single part geometries from stuff that has a bunch of multi-parts. This is a way to just get that done once if you're going to refer to it a lot. Moving on. Again, let's do some more interesting spatial kinds of queries. Suppose we want to find the number of parcels that intersect each of the precincts and order that by the warden precinct. We can use the st-intersects to do our spatial joining. And that way the parcel doesn't need to be fully within that precinct. So we'll select the precinct, which is the precinct name, the count of the feature IDs that are within the parcel layer from the precinct table, and joined to the parcel table based on this spatial intersection. So the precinct transformed into the UTM is on the same place as the shape. Admittedly, we could have used the MVW precinct here since we reprojected it. We could be using that instead of this ST transform. And this takes a little bit longer because there's a bit more going on there. But in 3 seconds, we now have counts of how many of each of how many parcels there are in each precinct. Which is not bad given that there are a lot of parcels in the city of Minneapolis. Another thing is that we can use functions within PostGIS and within SQL, and we can write our own functions if there's a thing that we want it to do that relies on a given input. So within the elections space, there's a 100-foot zone around a polling place building where certain laws and restrictions apply in terms of who can be there, what can they do. And so as an election administrator, GIS person, you may want a streamlined way to provide maps of what are these 100-foot zones to your election workers. And so we want a streamlined way to go from a point, that is our polling place point, then buffer the parcel or building that contains it by 100 feet. Note that they're a bit over 3 feet per meter, which meters are our map units. This create or replace function gets into some kind of advanced Postgres functionality on the stable and returns null on null input and parallel safe. If you're interested more in writing and functions, definitely look that up in the Postgres documentation. It gets pretty neat, but that's definitely not needed to get started. So that's an avenue for further inquiry. So we are going to create or replace that function, and I'm going to remember to make it a build.buffer zone. And we're going to run that. And it worked. So now if I refresh and look at functions, I have a buffer zone function. If we try that once, I'm going to run this in QGIS because I think I want to see the result. We select our row, we run our query, our ID is ID, our geometry column is buffer zone. It'll be buffer test 1. And if I zoom to that layer, maybe that was a little too close. Zoom to that layer, we can see that this is a reasonable size for a 100-foot buffer around around this location. Or yeah, 100-foot buffer, 30 meters. So that worked. We can then, with that function in place, we can make it really easy to do that for all of our polling places, because we can take the mock polling places, feed the geometry from that into that buffer zone function, and then use that resulting geometry. So again, we set our ID in our geometry columns. We can load that in. And when we zoom to that layer,
To me, this is like just so magical. You know, the idea of this, saying that I can have a query or a view in memory performing a buffer instead of having to create a new file or a new shape file or file geodatabase or feature layer somewhere.
yeah, you're absolutely right there, Mike. This is one of the really cool things, and it's about to get better, because in this next step, you know, that's a really useful operation. We want to do that probably a lot. So what we're going to do is we're going to actually make a view out of that. So in this case, we do want it to be rendered on the fly each time. So we don't need to store this result. We just want to be able to use this. So a view is a view you can think of as a shorthand for, here's a query that I'm going to run a lot. And if you're running the same query over and over and over and over again, it's a great candidate to make a view. They take up almost no space, and they then make it a whole lot easier to run those queries. So we'll, guess we'll create that here in the QGIS. I'll run that. It does its thing. And then we can simply select star from that view polling place buffers, select that, and execute it. That's easy. But in QGIS, it gets even easier, because if we refresh, I come down to main. Did it not refresh? Did it go into? Oh, yeah. I need to change my coordinate system here. So in QGIS, we need to change into the projected coordinate space, which then causes some of the layers to need to be reprojected. That's fine. And so now we have this view that's just sitting there as a layer that's in a layer that's available to us from that PostGIS database, and it's this polling place buffer. If we add another polling place to the underlying polling place data set, that will automatically show up and buffer in here.
Or if you delete one, or
if we delete one, or if we move one,
yep, the buffer will change.
The buffer changes automatically. You don't touch anything. It's just there and right. So that's where really the power of doing this spatial stuff within the database comes through, is that you can change, you can build with the queries, you can build pipelines of how do you want to analyze this, and you make one change in one place and it propagates through the rest of that pipeline for you. Yeah, so to do that, we first made a function that buffers our parcel, or buffers the parcel that's underneath a point. Made a view that then runs that function for each in the polling table. And if we move, everything updates automatically. Okay, so what about finding the nearest thing? There is an operator, which is sometimes given the informal name of the TIE fighter operator, for looking kind of like a TIE fighter, which provides the two-dimensional distance between two geometries. And it uses an index assisted, that is to say, fast result, only when it's used in the order by clause. But given that you generally, if you're looking for the closest such, you're going to want to be ordering by what is the closest thing. So that makes a fair bit of sense. So let's find the nearest 5 parcels to this centroid of Minneapolis Ward 8, Precinct 1. So we'll select the parcel number and the geometry, and we order by the geometry and how far it is from the centroid in UTM of the precinct, where the precinct is Minneapolis Ward 8, Precinct 1, and we only want 5 parcels. Apparently geom was shape. Sorry. There we go. So we get our 5 parcels and our 5 parcel shapes that are closest to that spot. We can then scale things up. So rather than looking at one precinct, now let's do it for all the precincts. So here, we are we want the precinct and some other stuff, a subquery, and yeah, we want the precinct and then this big subquery ordered by the precinct name. And the subquery is we want the oh, sorry. That's one subquery, and then there's a second transform. So we get the distance. This plugs into database manager. So we have 136 rows. The precinct name is unique. The geometry is unique. And we can see that for most precincts, the closest polling place to the centroid is in that, is within the same precinct, but there are some where it isn't. So generally the two numbers, precinct and the closest polling place, match, but there are a few cases where it does not match. If you're looking for things that are within a certain distance of something, we can use the stdwithin function. So in this case, if we want to find the parcels that are within 100 meters of a polling place, we again use our row number to give a unique ID for everything. We select the precinct name, the parcel feature ID, the parcel state PIN, the parcel geometry, where the parcels are within 100 meters, or map units, which here is meters, of our point. Sorry, again, the parcel geoms are actually shapes. Okay, the feature ID is RU.
Bill just typed, FID as FID2. That's another, aliasing column names is another just amazing time saver with databases. If your boss comes back and says, hey, I want that column to be labeled something else, super easy.
Yep. So we can run that. So now FID1 is the one that is our row number, our geometry column. If I had named it geom, it would have automatically figured out what it was, but it's shape. And this is going to be 100M. Parcels that are within 100 meters of the polling place. So we load that. We can put that under our buffers. And if we zoom in on some of these, take our polling places out, you can kind of see roughly where the polling place points were. And then anything that's within 100 meters of that gets added. So that's kind of a, and again, this could be made into a view if there were need to repeat this a few times. So that's, again, power of doing these sort of spatial queries.
That spot in the northwest with the linear, that's probably a multi-part parcel that of like right away or something, right?
Yeah, this is a right-of-way parcel, and you can see that it's interrupted at the roads because I believe in Hennepin County the roads generally are not parceled. Though, as with many things, the adherence to that standard, even within a county, can vary.
Phil, I'm wondering if maybe we're getting pretty close to our advanced considerations, so it's probably a good time to pause for questions, but I'm wondering if maybe you could demonstrate moving one of the polling places so folks can see how the buffer changes.
Sure. And I guess I see a question here from Nancy about what part of the polygon does D within hit. I would have to look at the documentation. I think it's any part of the interior would be my guess, is that any part, if D within hits any part of the interior, that would match. But I definitely would refer you to the documentation on that. So yeah, let's bring up our mock polling place data. Let's zoom in somewhere. We'll come here to Uptown. And if we were to move, so if we take this layer and we'll enable editing, and we'll take this one and we'll put that here at Lakewood Cemetery. And then we will save that layer edit. And we will move the map a little bit to get it to redraw. And now that's updated. So if we move that again to somewhere else, save it, we can move the map to redraw, and all of our buffers move with it. So that's where this gets cool, is that you can have, in this way, you know, if you've got users who are updating points and you've got viewers who are looking at these buffers or these other things, one person updates it, you don't have to recreate feature classes, you don't have to re-export, re-import, it just goes. And it all happens in real time. Okay, any other Any other questions or things folks want to talk about before we get into some of these more advanced considerations? Hearing none, we will proceed. So this workshop is intended as, again, as an introduction, a little bit of things that you can do. But there are some advanced considerations that you should be aware of. And a lot of these advanced considerations are around indexing and database performance. So while you can get started without an understanding of the indexing and some of the special cases, you may run into performance issues eventually. A way to think about that is, this is kind of an introduction. It's like learning how to back the car out of the driveway. You know, we've given you enough info to be able to take those first steps, but you may eventually encounter an interstate. And if you are trying to drive down the interstate in reverse, it's going to be a very difficult time. And one thing that I like to kind of keep in mind as I'm working with PostGIS and PostGIS is, if something doesn't work very well, it's entirely possible that if I knew the right way to do it, it would actually work a lot easier, because a lot of the things are easy. So adding an index is one of the sort of go-to things that database administrators go to for how to make stuff faster. It's like, well, use an index. In spatial world, now you have a spatial index. By default, PostGIS indexes spatial indexes are two-dimensional, although you can request higher dimensional indexes if you want, and they will, those can be accommodated, and then you can do all the fun high dimensional spatial indexing fun. So spatial indexes for lines and polygons, spatial indexes will use the bounding box as a rough approximation of the feature that it's indexing. And that's cool, because it means that when you run a spatial function like st overlaps or intersects or touches, the spatial index can quickly go through and it will say, well, what things can't overlap, intersect, or touch? And I don't have to check those, because if the bounding boxes don't overlap, they definitely don't overlap or touch or intersect. And then once the number of rows gets limited by that first pass, then the more expensive computation can be run on a much smaller subset of data. So to that end, the spatial indexes work best when you're comparing things that are of similar sizes, and when the bounding box is a good approximation of the feature. So, for instance, if you want to find parcels within 100 meters of US Highway 169 in Minnesota, based on, you have a road center line, you want to buffer that by 100 meters and see what parcels that intersects. That probably won't work particularly well, because Minnesota 169 has a huge bounding box. It includes the Twin Cities Metro. It goes a long way. Let's see if I can bring up. Okay, so here's Minnesota, and Minnesota 169 runs from up here in the Iron Range down past Lake Mille Lacs through the cities, down towards Mankato, and ends up at the Iowa border. And so if we go by bounding box, everything that is, you know, anywhere in sort of this east central third of the state or east central quarter of the state is going to be in that bounding box. And that's the entirety of the metro. But most of those things aren't within 100 meters of the of 169. And so if we use, if we break up that highway into smaller pieces, each of those smaller pieces has a smaller bounding box. And that can let us then get that leverage that we need to make that spatial index work really quickly for us. So if you split that up into 50 different pieces, now you can be doing a much faster indexed search to do that geometry comparison. In the case of linear features, you would first need to use the ST segmentize function, which will add segments to a line, or take a line and make sure that it has more segments. And then you use the ST subdivide to actually split that into different pieces. Then with those different pieces, those can run against the spatial index and be very fast. Similarly, ST subdivide works with polygons. So if you have a big geometry like Canada, or a really high resolution county outline and have a bunch of islands or things like that, you can use the ST subdivide to make everything smaller, and that way it's easier to it's easier for that index to work with it. The next thing, and this is a straight up PostGIS thing. This has nothing spatial about it, but databases do need periodic care and feeding. And when you have transactions against a database table, you eventually need to make the storage available again for rows that were deleted. And that can be done using the vacuum command. Also, the database maintains statistics on the distribution of data within a given column. So if you're making lots of changes by adding a bunch of new data, it can be helpful to run the analyze command so that the database has a better idea of what data is in the column so that it can better plan efficient queries. And those two commands are often used together as vacuum analyze, which will, again, free up that deleted row space and then refresh the statistics. Going beyond this, there's, of course, a ton more. There's always more to learn about this. Hopefully you've realized that there's a lot that PostGIS can do, that there's a lot that PostGIS can do for you fairly easily, and then there's a lot that it can get into. We didn't get into linear referencing, but if you want to do linear referencing, you can do that. I've done a little bit of work with some linear referencing and working with LRS features using PostGIS. It's pretty cool. There are 3D operations if you need to work in 3 dimensions. There are specific time series and trajectory functionality that's out there. And there are extra, oh, it also works with rasters. So if you have raster data and you want to do things like sample within 100 meters of a point and find what's the raster value for something, what's the vegetation index averaged over that space that's within 100 meters of a given point. You can do that. There are extensions. The PostGIS Tiger geocoder is a free batteries included geocoder that uses the census's road center lines data set to be able to geocode things. So if you've ever wondered where is 658 Cedar Street in St. Paul, you can feed that into the Tiger geocoder and it will give you an answer that's reasonably correct. It does work off of address ranges, so you probably wouldn't want to be using it for, your delivery service probably wouldn't find the geocoding sufficiently accurate. But if you're doing a statistical analysis, it probably is good enough. Also, there are extensions like fuzzy string matching and an address standardizer, so that if you're doing, if you need things to match that are close, oops, somebody mistyped an address. Let's see if we can figure out what they actually meant. Some of that is built in as well. There is a big list of PostGIS functions. It is a big list. It starts with, data types, some table management things, how to make different geometries. You can make hexagons. You can make hexagon grids. So if you're running that Dungeons and Dragons campaign and you need to make a map for it, you can generate a hexagon grid for it. All kinds of fun things that you're able to do. Getting out the nth ring, or getting all of the rings. Another thing that I didn't talk about much previously or at all is that you can also, there are geometry validation tools. So you can check if geometries are valid. If they're not valid, you can ask it, why are they not valid? And there's also a make valid function that will turn things that aren't valid into things that are, or at least try very hard to do so. The later versions of PostGIS, so certainly 3.1 and into 3.2, have the ability to use a sort of fixed precision geometry grid, so that if you want to run operations where everything is snapped to the nearest millimeter, you could do that. And that makes some of that geometry validation easier, because then you aren't worrying about some of the floating point math that you might have. So that's available particularly in the 3.1 and later PostGIS versions. So lots of cool stuff to find there. You can find out all sorts of different things that you can do if you want to shift geometries by a specific amount. You can shift geometries. There's a lot here to find out about. Another place to find things is in the PostGIS documentation, because a lot of being good at PostGIS is also can come from knowing how to use Postgres, how to set up user accounts and access control, how to set up indexes and views, and those kinds of things. Having just the data, you can't just learn the spatial part without necessarily appreciating some of the Postgres part. They really do go together, particularly because the Postgres part will often make queries faster and more reliable, because there are parallelization tools that you can use. As for how to get started with Postgres if you don't have it or if you wanted to play with it, both Azure and AWS offer managed database services. So today we've been using, our database today is in Azure. They both have managed database services that have both Postgres and the PostGIS extensions. However, if you need Esri ArcSDE for compatibility because you have versioned databases or things of that nature, those options may not work for you. So that's one potential problem. If you're looking to sort of host your own stuff, PostGIS also has a number of combinations of versions that are available via Docker. So I've found this really fun for those times that I need to just, I need a PostGIS database to try something out or play around with something, test locally, and I can use a Docker container with PostGIS and have it up and running in a few minutes, asterisk, if I have Docker installed and know a few things about Docker. But those things can be installed and can be learned, and that makes it really easy to try out different versions of things and play around with that. Also, Crunchy Data is a database support company, I think based out of Canada. And they have for several years sponsored a PostGIS Day conference. So GIS Day is typically the second or third Wednesday in November, and PostGIS Day is the Thursday after GIS Day, because somebody had a sense of humor. And those talks, at least for 2019 and 2021, I think 2020 was skipped because pandemic, but for those 2 years, the playlists are available online, and there are some really cool talks, including some great ones from Paul Ramsey, who's one of the PostGIS developers, on all kinds of different things that you can do with PostGIS, things that people are doing with it, new features that have been coming out, how to use geocoding, what are some other options for geocoding, why, things that they've been doing to make it faster and why it's faster. So those are definitely things to check out and take a look at.
Hey, Bill, if things get loud for me here, I'll move to chat, but I asked a question in the chat just above my latest comment, and while you check out that question about how easy it was to set this up in Azure, I just want to mention that with Esri and ArcSDE, it's absolutely doable. So if all you need to do is read from the PostGIS database, the Esri products do that just fine. So if you're comfortable doing your editing in QGIS and all your reading and reporting and symbolization, maybe your services or analysis on the Esri side, then that can work really well. If you want it to be all Esri, you just have to do some extra steps on setup of the database. So you can still run the database on PostgreSQL. You can still have the PostGIS extension installed. You just have to take some steps to sort of Esriify the database. And that's not really well documented, but it is doable. And there are several folks that have done it. And if you dig hard enough on like Stack Overflow and a few other places, it can be done.
Yes, it can be done. It does seem like it isn't actually a thing that can be done on some of those managed services, because you may not have the access that you need to be able to do some of that.
Yeah, exactly.
But yeah, you may end up having to go the route where you build your own virtual machine and administer your own database rather than use the managed ones. So Mike, you were asking about how easy was it to set up this database for this workshop. It was a matter of, I mean, I'll admit that I work with Azure on a daily basis, but setting it up was a matter of about half hour or so. You sort of select, I would like a database, please. It should be Postgres. Once the database is created, you tell it, I would like the PostGIS extension enabled. It says, okay, it'll restart, and 3 minutes later, you are in. So it really, it was very easy to get this going for the workshop today.
That's really cool, and that's good news, because my organization is going to be migrating quite a bit to Azure in the next few years, and I'm hoping that I can go to Postgres and PostGIS as part of that, because that's my plan. I don't really edit all that much data. I have a handful of data sets that I edit regularly, and I'm comfortable doing that in QGIS. And then everything else will just, all the Esri tools that I have will just be for reading and reporting and analyzing, and they'll be able to do that out of that native PostGIS database, and it's going to save me a lot of time.
Yeah, and I didn't talk about it a lot here because I don't have much experience with this yet, but I'm really excited for the as MVT, the vector tile export options, because there are a couple of very small sort of add-on services that you can get as they're available, again, primarily as Docker images. There is PG tile serve and PG feature serve, which are a vector tile server and a feature server, respectively. And you can configure those to sit in front of your PostGIS database, and they will serve up vector tiles of a given table or view, or tables or views. And so that way you can, I believe at the moment that they are read-only, so you can't use them to be an editable feature service. But certainly if you're setting up the viewing side of your of an application, those can integrate really nicely with the PostGIS backend. PostGIS is then generating the vector tiles right there at the database, and you can just export those, and it serves those along to the web clients. It should be really slick, and that's one place that I'm looking forward to playing a bit more in the next few months. Okay, so Nancy's asking, would that eliminate the need for map server? Sort of. It's that would be kind of replacing the map server. So it would be, yeah, by serving the vector tiles, it means that the client can do you do end up with client side rendering, and so it's easy for the client to specify how they want it rendered. Whereas with map server, that was typically configured at the server side, and the server then just sent images of, you know, here's the PNG image that would be displayed. By using it as the vector tile, it means that the client can say, oh, I want that road to be green, not red, and it can do that. And yeah, it's pretty fast.
Yeah, I put an example in the chat. Our colleague Jennifer Strahan, who now works for the MPCA, put together that map at her last organization, and you can see all those little blue parcels. They draw really fast, and there's a lot of them, and they're all rendered with vector tiles. So yeah, Nancy, I mean, you may still need your map server for some other components or something like that, but if you've got something that's really a lot of vertices and a lot of polygons, kind of like your spray areas, you know, creating vector tiles could really speed up your web map.
Yeah, and another thing that you can do to kind of simplify things if you're going to be web mapping stuff is that you can, if you do an ST buffer, you can give it either a positive or a negative offset. And so what you can do is you can buffer, you know, buffer it by 100 meters larger and follow that by a buffer 100 meters smaller. So you end up with roughly what you started with, but that can end up shrinking the number of vertices that you have, and simplifying stuff. So then you're putting a simpler output to your web mapping, and that can make things faster as well.
Yeah, that's another thing I tried in SQL Server that did not work. I could do a basic buffer, but I can't double up on the buffer.
Yeah, any other questions on some of this? Oh, okay. Well, since we've got a little bit of extra time, who wants to guess the smallest parcel, size of the smallest parcel in Hennepin County? Okay, so that's a storage unit. Okay. Actually, we can use stmin. We'll start with stmin. So we run that, and just to be clear here, it took 0.4 of a second to look through all of the to compute the area of all of the parcels in Hennepin County? And our answer was 0.053 square meters.
Now we all want to know where that
Teeny
is.
Okay, we want to know where that is. Actually, how about we look at, say, the top 10? So we're going to use the limit to only get 10 results. And we need to order it by
You can order by the alias?
I believe so. We'll find out. Yes, I can.
Another thing SQL Server doesn't understand how to do.
Okay, and it's automatically figured out that our geometry column is the unique part, or is the geometry thing. We'll tell it that the state pin is hopefully unique. It's not actually guaranteed to be unique. So let's load that in. Small parcels. Zoom to it. That stuff off. We are going to open our style dialog so that we might have a chance of finding some of these. We're going to make that stroke width. We're going to make that bigger. Maybe not that big though. Okay. So we've got one up here. Oops.
Min.'s fault.
Yeah, it's going to be MnDOT. Only one of them is MnDOT's fault. I would bet that the rest of them are survey markers, though.
One of them was a golf course. Maybe they made a specific parcel out of their 18th hole.
Yeah, so that's how you can find what's the smallest of this. So this one, we can identify that. And this one's state of Minnesota. This is probably a MnDOT one. It's in a very MnDOT place.
Well, go for questions, I think. We've got a little less than 10 minutes left.
Will we have access to the VM for a bit after class? Yes. So this will be there probably in about half an hour or so. I am going to make it much smaller. So right now, because of the magic of cloud computing, it is currently an overwhelmingly large 16 core by 64 gigs of memory machine, which is far larger than it strictly needs to be. And at about 12:30, I do plan to make that smaller again, so that it doesn't rack up big bills. But it's going pretty big at the moment. So that all of us can be on it. We can play around, and nobody's affected by performance issues. And also, I had free credits with Azure, so yeah.
Hi, this is Andrea. I just wanted to maybe go a little further with that. So will we be able to connect like tomorrow or next week, or how does that work?
Yes. Well, yeah.
Or does it not work?
It works. I can. So right now it's got a firewall in front of it, so it's only accessible from my IP address and from Azure resources. But I know that there's interest in this. I will go ahead and open that up, so that yes, it will be available at a small size. So 1 or 2 core and 2 to 4 gigs of memory kind of size, which is still plenty powerful. I was doing all of the testing and building this on the small size, and I was not waiting around for much. These data sets are small enough that they're not a big deal. But yeah, I can leave this up for a few days, and folks can play around with it. And I'll even open the firewall so that you can actually get to it outside of the Azure network. That said, you will want to make sure that you have the connection information, like the host name and the port and all that stuff saved if you're going to want to continue to access it. So thanks everyone for coming. I know that there will be a feedback form coming along sometime between now and probably a couple of weeks from now, but I guess it'll come sooner rather than later. Please fill those out, and we'd love to hear feedback, especially because we might well be putting into to try this again with the workshops for the fall. So thanks again.
Yes, and thank you, Mike and Bill, for putting on this great workshop.
Glad to do it.
Yeah, you're welcome. And yeah, it's always, keep in touch. It's always fun to hear what folks are doing with the technology that's out there. So thank you much.
Absolutely. Well, you guys are right on time. If everyone can feel free to log off, and thank you so much for attending the workshop today. Have a good day.